Hi everyone, I'm Franz and today I'll be showing you how to measure voltage, current, and resistance. But before that, let us first troubleshoot the circuit and components before assembly. Why? Because troubleshooting during or after an assembly is costly, time-consuming, and more complex. So, troubleshooting before an assembly allows for the most easiest and cost-effective fixes. Before using multimeter, insert the black test probe into the COM jack and the red probe into the V ohms milliamperes jack. For troubleshooting, set the multimeter to continuity test mode. Since this multimeter has no continuity test mode, we can use diode mode for continuity testing. Diode test mode is used to check if a diode is working correctly by measuring its forward voltage drop and ensuring it blocks current in the reverse direction. Test the multimeter by touching the two metal tips of the probes together. The 001 reading result, or nearly zero, confirms that the probes are not broken. The multimeter is functioning correctly in this mode, and there is a completed circuit between the probe tips. To test the components, place the red probe on the positive terminal and the black probe to the negative terminal. For example, when you are testing an LED and a battery, because they have polarity or the positive and negative terminals. If the component has no polarity, like a resistor, you can generally place test probes on either of its tips. Now, let us troubleshoot or test the electronic components that we will use in our circuit. The LED lights up, which means it's working. The reading is 1, which most likely indicates that the voltage supplied by the multimeter's diode test mode is too low to forward bias the red LED. This is a common issue, but it usually means that the LED is working correctly, not faulty. The reading result of this resistor is approximately 322 ohms, which is quite accurate because I used 330 ohm resistor. This red jumper wire has a reading of 0.002 volts or near zero resistance, which means that the wire is healthy, indicating excellent continuity. This yellow jumper wire has a reading of approximately 0.003 volts or near zero resistance, which means that the wire has a solid electrical connection. This orange jumper wire has a reading of 0.005 volts or near zero resistance, which means that the wire is good since it has very low resistance. Let us now start measuring voltage, current, and resistance. Turn the multimeter to 20 direct current voltage to measure the voltage of a battery. The reading result of this battery is 9.15 volts, which is accurate because it is a 9 volts battery. The reading result of this LED is 5 volts. It is 5 volts because I used the 5 volts pin in Arduino Uno. But let us use a resistor so that the LED will not get damaged. The voltage across this LED is around 2.85 volts, while the voltage across the resistor is around 2.25 volts. When you add them, you get 5 volts, which is expected as Kirchhoff's voltage law states that the sum of voltage drops around a closed loop is equal to the total applied voltage. To measure the current, turn the multimeter to 200 milliamperes. Measuring current is different. You must put the probes in series with the circuit. The current flowing from the resistor to LED is around 6.5 milliamperes. Without a resistor, the current through the circuit is 20 plus. To measure the resistance, turn the multimeter to 200 ohms. The reading result of this resistor is 324 ohms, which is still accurate because it is a 330 ohms resistor. After using the multimeter, turn it off to conserve battery life for future use, and remove the two test probes.